So after 1 month, I made 50 cents. After 2 months, I made $1. After 11 months, you could say, I made $5.64 in interest. So you keep doing this, and then you'll see that interest will accrue. So why is this important to this thing here? This question. Well, that first $100, I'm keeping it for 36 months. So I'm going to accrue interest on it for 35 months. Because the first month doesn't count, because the first month I deposited, I didn't actually make any interest on the first month. But then for 35 months after that, I made interest. So that's going to be 1.05, 1.005 to the power of 35. And then answer times 100. That's going to be $119.07. 7 cents. Okay, so that's the scenario if I just deposited $100 and then for 3 years, compounded monthly, I just let it sit in the bank and just grow interest and I didn't touch it. But that's not the case here. Here, we are depositing $100 every month. So this amount, I'm going to add it to another $100 that I deposited 1 month later. But because I deposited 1 month later, I don't have 35 months of interest on it, and now I have 34 months of interest. Because I deposited this on month 2. So that means I'm going to get now interest on $100 for 34 months. So I'm going to do 1.005 to the power of 34, and then times that by 100. 118.48. 118.48. So the difference between these two values is just 1 month of interest. It's just 1 month of interest. That's it. But now guess what? I deposited another $100 at month 3. So now I'm going to have another $100. But now in this scenario, I don't have 35 months or 34 months. I only have 33 months because it's 1 month less than the previous. And that value is going to be $117.89. And I keep doing this because an annuity, basically that's what we're doing. We're calculating the compound interest for each individual deposit. Now, you can do it this way, and it would take a really long time because we would have to do calculations like 35 times and then add them all up. But luckily with math, since we're adding a whole bunch of terms, that's like the sum of something, right? Which we actually did in geometric series, right? But we're not going to be doing that right now. I'm just going to show you the formula. Some mathematician back in the, I don't know the history about it, to be honest, figured out that, you know what, hey, we can just use a formula to do this, to add all these terms up. And just so you know, the last deposit, that deposit on the 36th month, will have no interest on it because it has to stay in the bank for at least a month. And since I'm just depositing it that month and I'm not holding it, so the last deposit that you're depositing on the 36th month will have zero interest, zero. So it's going to be 1.05 to the power of 0. And there's a pattern here, 0, 1, 2. So the deposit, the second last deposit, on let's say the 35th month, will have interest accruing on it for exactly only 1 month because it's only been in the bank for 1 month. And the third last deposit on the 34th month will have interest accruing for only 2 months. And so forth. That's what these dots mean. And I'm going to add up all these values. So the timeline, this is how you make the timeline. You have your n value of, in this case, 3 times 12. So n is 36. you always start with a now as your initial timeline, and then you start counting. 1, 2, 3, 4, 5, 6, all the way up to 36. Now, you don't need to, unless if the question is specifically showing you to show every single deposit in every single month. Usually, what standard practice is to show the first 3 months in the timeline, and then ... and show the last 3 months. And if you don't know what the last month is, it's always your end value 36, and then you just subtract 1. And that's how you show your first 3 and your last 3. And then you just show the deposit, the equation for the deposit, which is 100 times 1.005 to the power of 35. And then the deposit for this guy is just 100. There's nothing happening. Deposit for this guy is 100. 1.005 to the power of 1. And for this guy, it's 100. 1.005 to the power of 2. And if for the 2 guy, the exponent is going to be 34. And if for 3 guy, the exponent is 33. Just the exponent is just changing by 1 because 1 month, right? And that's how you show your timeline. That's important, especially when you take economics in university. And I guess this course as well. Do they offer economics in high school? I don't know. They might, depending on the school. All right, so we drew the timeline. Now we have to determine the amount in the account after 3 years. So let's use this formula. Oh no, I actually need these values. What am I doing? Okay. So A is the amount after all those years. R is my regular payment. How much am I depositing each month? Well, that's this value here, $100 each month. That's 100. 1 plus I, which is 0.005, so I'm just going 1.005 to the power of n, which is, remember, n is the number of years times j, so 36, minus 1, all over 0.005. That's my I value. Don't confuse I as the interest rate given. That's wrong. Your I value is always the interest rate divided by the compounding frequency. All right, let's do this. So 1.005 to the power of 36. $1.005 to the power of 36. So that's this inside bracket. What is it? 1.196. All right, so you do minus 1. So this value, answer, minus 1. And I have a decimal. And you times that by 100. Okay, now I have this value here. And I should be writing all these values down, so let's just write down 19, what is it, 0.668. And you do not round off anything. See, just because I'm not writing all the decimals, if you realize when I'm doing the calculation, I'm not rounding anything, right? All right, so 19.668 divided by 0.005. That's answer. Divided by 0.005. And the final answer is $3,933. And 61 cents. So this is the total amount of the annuity. What does that mean? Well, remember how I was depositing $100 each month? How many deposits did I do? I did 36 deposits. 1 to 36. So if I did 36 deposits, $100 times 36, remember this is my N value, this is my R value, you get $3,600. That means $3,600 of that money was my own. So I didn't just make $3,933. No, $3,600 was the money that I actually deposited myself. But in terms of the interest that I, quote unquote, made, you just have to subtract these two values, sorry. And now you'll see exactly how much money the bank gave you. So they gave you $333.61. That's how much interest you made. And that's it for today. Unfortunately, I did not have enough time to go over the final lesson, but I did pretty good, I would say. Went over quite a bit. So part 5, you got to do on your own. There's nice examples here with solutions. So definitely look at those timelines, solve it. You can definitely do it. All right, good luck, everyone. Remember, your quizzes are due. Your quest, quote-unquote quest, are due tonight and tomorrow night. And your culminating will be released tomorrow. We'll talk more about that. Take care. Bye, everyone.